What's going on, my chemistry students? Let this party started. My voice just went too fast for my brain to be even able to catch up, so I just started stuttering a whole bunch. What's going on, my chemistry? The party started. Anyway, I will try to get through this stuff and make it as fun and cool and interesting as possible. To be honest with you, you guys want to know a secret? Is to be honest with you, this stuff isn't as fun to me as what's coming up in chapter 5, which is gas laws, which is amazingly cool because it has the most to do with physics to me. So now you guys are thinking, oh, well, now that made it so much less cool because, we heard the way you act in physics. It's crazy. So anyway, all right, whatever. Actually, and Alana, I'm going to try to make everything in the lab that we do on Wednesday something you can do at home. You might need to bake your baking soda, and you might need to get your hands on some hydrochloric acid, which is also known, or some different kinds of bleach. But I'm going to try to make everything that in the lab so that way you can do it at home if you miss the lab. Anyway, I was really interested in a homework assignment that I gave you. Was this it, the concentration one?
Yeah.
Molarity? Let's take a look at it. I want to do question 29. Part D. All right. Here's what I got. This is the best you can. Oh, okay. Here's what we got. All right. So let's take a look at it and see what we got. Because this would be a good place for us to start with. This would be a good place to start with us being able to. A good place for us to start today's lecture with. Let me give you guys the big picture of what we're doing right now. We're balancing equations. And we're using that information of the balanced equation. Now, with precipitations, we have different forms of that balanced equation. We have like the net ionic equation, or the complete ionic equation, or all that kind of stuff. And so that's something new that you haven't seen before. But we're taking this balanced equation and we're using it to convert between chemicals, or parts of a chemical for that matter. Now, in order to convert between chemicals, the only stipulation on this stoichiometry thing is it all has to be done with moles. With moles. It all has to be done with moles. And my 6-year-old daughter is looking at me and like, moles? What are you talking about? Moles. Yes, moles. And Bradley's like, my favorite, because it's not his favorite at all. Anyway, all right, whatever. Sorry, Bradley. So anyway, let's do this one because it's not really that bad. I don't think it's that bad. You guys think it's bad. Well, let's try it, okay? I'm dealing with potassium phosphate, K3PO4. Okay? And I'm thinking that if it breaks down, or what they're asking me to do is find the ions present. So what I should probably do is figure out what ions make potassium phosphate. I know my potassium, which is usually a plus, and I know my PO4. I can look up the table and I think I get a -3 on that. It's also pretty easy to see because I need 3 potassiums to balance out 1 PO4, so the charge on that PO4 must be the -3. Did I lose anybody yet? No? Yes? Okay, all right, good. So here's what my thoughts are. I'm going to start off with my 1.00 grams of this stuff. And I'm going to divide it by 250 milliliters. Do you understand why I divided it by 250 milliliters? Because usually when we're talking about a concentration, we're talking about grams per milliliter. Actually, we're talking about moles per milliliter. So I need to convert that to moles of something. Okay? So let me just go through and play this game until I figure out the moles of something. What I'm going to do is I'll probably multiply this by 1,000. Because the reason why there's 1,000 is because I want to get rid of these milliliters, because when I'm talking about molarity, my units that I like dealing with is liters. Nothing freaky there. If it's all right with you, I need to divide this by, I think it's 202 or 212?
212.26.
212.26 grams for 1 mole of K3PO4. All right, I jumped a step right there. Let me know if you're freaked out. Say, wait, what did he do? Where did he get that number? What's going on? Anyone freaked out? Okay, Bradley, you identified it already. That's the molar mass. That's the only thing that I can do to mess with your brain, really. Is I didn't give you the answer in moles. You need to get it into moles. So in order to get it into moles, you need to use the molar mass to convert it, because I gave it to you in grams. And whenever you're going from grams to moles, you need to use this thing called the molar mass. We cool with that? Everyone besides Bradley, are you guys good with that or no? All right, good. And then this tells me the moles of K3PO4. So what this equation is saying right here, maybe I should use a different color. What this equation is saying right here is that if I have 1 mole of K3PO4, in order to make it, I need 3 moles of K and 1 mole of PO4. You got it? So I know I'm deviating from the problem just a little bit, but why don't I do this? I'm asking you, give your answer for the number of phosphate ions. What I want to do is give me the answer for the number of potassium ions. I'm going to change up the question a little bit. So I can use this conversion factor right here as my next parentheses. I can say, well, for every 1 mole of K3PO4, it gives me, I need 3 moles of K plus ion. Where did I get that? Well, I got that from here. That's the stoichiometry part of this game that we're playing. Does that make sense to you? So now you use your calculator and you multiply. Well, you take 1, you divide it by 250, you multiply it by 1,000, you divide that number by 212.26, and you multiply that number by 3. I don't know what that answer is. Let me go to good old, all right, 1 divided by 250 times 1,000 divided by 212.26 times 3. Yes, I would like to lead H. The answer is 0.05653444. All right, 0.05653 moles of K plus per, let's see, what units canceled? This units cancel, don't step on that, Shy. This units canceled out with this units over here. The grams cancel out with the grams. The moles cancel out with the moles. And I'm left with moles of K plus per liter, which is really just the molarity of your K plus ion. Done. Does anyone have any other questions on this, or does this seem pretty straightforward and easy? Not bad, bad, good, ugly? What's your thoughts?
Is that the answer you got?
That's the answer I got for the K plus ions. For the regular, when I told you give me for the phosphate ions, all you would do is you would say, well, the conversion I would use is actually 1 mole of potassium phosphate gives me 1 mole of phosphate. So literally, I think that I would just cut this part of the multiplication out. So whatever this answer is divided by 3, that's my answer that I would put in for this question part D. And I think, actually, and I only changed it this morning, I forgot to tell you which ion I was looking for. And so I changed it to fix it, to make it correct. And I apologize for putting it in wrong. You should have free reign on this question. Let me see. Stoichiometry, solution, molarity. I'll tell you what I'll do. And I'll do it for you while I'm sitting here right here. Chapter 4, concentration. Is this it right here? All right, so for everyone who turned it in, 19. I'm going to give you 5 extra points. That is, of course, if you turn it in. And I'm not going to give you extra credit, so, I mean, I'm not going to give you more than the points are worth. But, so if you got 23, I'll give you 23. If you got 15, I'll give you 20. And over here, you get 13. Over here, you get 8. 21. I'll consider that a attempt. 23 already. I'll give you an 8. I'll give you 23. I'll give you a 6. I'll give you a 5. 17 plus that is 22. And I'll give you a 17. There we go. So I gave everyone 5 free points because I screwed up asking the question correctly. Actually, I didn't really. I didn't really screw up asking the question. Did I? I more screwed up the. I guess I didn't ask you the whole question. So there you go. 5 extra points. No one can complain about what I just did. Or you can complain if you want, and I'll change it back for you. How's that? All right. Let's do another review problem, and then we'll get into acid-base reactions. Because these really, they look hard. They're not that bad, I think. All right. Anyway. Last week, Bradley and I had this whole conversation about, well, what makes something react and what makes something not react? I mean, how do you know that? Those are important questions to ask. I agree with you, Bradley. Why don't we do this one? Ready? What do we know about... all right, so in an aqueous solution, Na2SO4, all right, so sodium sulfate, Na2SO4, and lead nitrate, so that would be PbNO3, 2, are mixed. The PbSO4 precipitates. So we know that PbSO4 creates a solid. And that's what the problem tells us, literally. So calculate the mass of PbSO4 that is formed when 1.5 liters, so 1.5 liters of 0.0500 molarity of PbNO3 is combined with 2 solid liters of 0.025 molarity Na2SO4. All right, and when I mix those, okay, because I'm doing this problem kind of as a review before we get into acid and bases, and also maybe to teach you this concept of limiting reactions, which I think that I got into with you a little bit, but I'd never really talked about it fully. I just kind of, well, you'll see what's going on. Okay, so what I'm going to do is I'm going to say, all right, well, Na2SO4, if we go back to our chapter 7, and actually I want you guys to print out this thing for me, is, well, what happened? Where is it? There it is. There it is. See this table? This table we've gone back to a lot this whole semester, right? This 4.1 table. I think I'm going to actually ask everyone to print that out for me. But let's see. Na2SO4, does that dissolve? And the answer is yes. It's an aqueous solution, right? Because of rule number 2. And also, most sulfates are soluble. So, rule number 2 and 4 says that Na2, there's 2 of those, and SO4, there's only 1 of those, so it's got to have a -2 ion in it. And if I add in lead nitrate, and all nitrates are soluble, so Pb plus 2 plus NO3 minus 1. Oh, oops, I forgot to put something. There's a 2 out in front there. All right. Anyone confused as to what I wrote down? This is all the stuff that went in the mix. And I know that Na2SO4 is an aqueous solution, and I know that lead nitrate is an aqueous solution. Cool? And they told me that lead sulfate, so PbSO4, actually is a solid. We cool? And let's see. And I know that the other compound that must form was actually the NaNO3, the sodium nitrate. But the sodium nitrate actually is still soluble in the water because we have the nitrates are soluble, and also rule number 2 says the sodiums are soluble. So on the right-hand side, I'll still have my plus Na and my plus NO3. And the reason why I wrote them separately is because they dissolve in water again because of rule number 1 and 2. Are we cool with that? And I'll probably want to have 2 out in front here, 2 out in front here. And that is the complete ionic equation. However, if I wanted the net ionic equation, I know that this guy right here and this guy right here cancels out with that guy right there and that guy right there because they were just spectator ions. We've talked about that, right? So my balanced solution is SO4 -2 plus Pb positive 2 gives me PbSO4 solid. Gives me a precipitate. They were aqueous, so they dissolved back. Yes. Actually, what it's saying is they were aqueous and they still remained aqueous in the end, so they never really changed. They never really reacted. They just kind of are still there. They're not doing anything, they just were still there. Okay. All right. So what I want to know is if I had, here's the interesting part of the question, is this isn't that hard stuff, but if I had 1.5 liters of this stuff over here, the lead nitrate, and I had as much of the other solution as I wanted. So disregard the fact that it says 2 liters of something, but let's pretend that I had a barrel of sodium sulfate. Just unlimited amount. How much lead would I get? I guess that's what my question is. How much stuff would I get in the end? So if I had an unlimited amount of the other stuff, but I had 1.5 liters of this stuff, then let's see. I know that 1.5 liters of PbNO3, and I also know that I want to multiply this by 0.5, I think. Yeah, 0.0500 moles per liter of PbNO3. Why did I multiply by 0.5, by 0.05, as opposed to divide it? Why did I multiply by this, as opposed to divide it? Because this is 1.5 liters, I want to figure out exactly how many liters of the stuff that I have. Does that make sense?
Oh, yeah.
Or I want to figure out, is I want to cancel out the liters. So this liters cancels out with that liters. And I'm left with moles. So now that I have moles, I can use my balanced equation to figure out exactly how much lead sulfate I will have. I know that for every 1 mole of the PbNO3, I get, or for every 1 mole of Pb ion that I have 1 mole of PbSO4. So I have 1 mole of Pb ion gives me 1 mole of PbSO4. Does that make sense to you? All right. So then you plug that into your calculator. What is 1 point? Oops. I think that I messed up the question. This was supposed to be 1.25. Sorry. What is 1.25 times 0.05? And you end up getting 0.0625 moles of PbSO4. Are we cool with that? Why is that the opposite? No. Oh, okay, never mind. All right, got it. All right. Now what I'm going to do is I'm going to say, well, what if I had only exactly 2 liters of this stuff, but unlimited liters of the other stuff? How many moles of PbSO4 would I create? You see what I'm saying? All right. Well, if I had exactly 2.00 liters of Na2SO4, and I wanted to convert that to, man, class goes so quickly. I got to finish at 2:55. That is ridiculous. I don't know how I'm going to get through any of this stuff. I haven't gotten to new chemistry yet. I'm just doing review. This has happened to me all day. I actually have to hold another algebra class just because I didn't cover any new material. All right, anyway. If I have 2 liters of Na2SO4, and I want to get that into how many moles of PbSO4 I will actually create, this would be for every, let's see, the molarity of this is 0.025 moles per liter of Na2SO4. And then I know that there's 1 mole of SO4 ions for every 1 mole of PbSO4 that's created. So I know that if I multiply 2 times 0.025, then I would create 0.0500 moles of PbSO4. All right. Does everyone understand what I did? There's an important concept that I need to get across to you. Do you understand what I did so far? I said, if they gave me 2 different amounts of liquids, and I said, if I start with the first amount and I react it with as much NaSO4 as I want, this is how much lead sulfate I could form. Got it? If I reacted it if I start with the second liquid and I reacted with as much liquid as I want of the first liquid, this is how much lead sulfate I could get in the end. But here's the thing. Which one? I guess the question is, how much lead sulfate are you going to get? Do you understand the question? And I don't mind. You know what? I'll tell you what. I don't mind pushing the homework back even more. I know I pushed it back a week. I'll push it back a couple more days because this is an important concept for me. How much is actually going to react? How much are you going to get in the end? I'm going to throw this out there and wait for your answer. What are your thoughts? What is actually going to happen? Do you guys even understand the question? Yes. I agree with you, Bradley, that I will get PbSO4 in the end. Yes. But how much am I going to get of it? Am I going to get 0.5 or 0.05 moles worth of that stuff? Or am I going to get 0.0625 moles worth of that stuff? Because I have two answers. Well, if I inputted 2 liters worth of, well, the molarity of this was 0.025 molarity of Na2SO4, and I also had another beaker that only contained 1.5 or 1.25 liters. Of a higher concentrated 0.05 moles of PbNO3 lead nitrate. My question to you is, in the end, if I added those two together, how much solid lead sulfate, because I know that PbSO4 is going to be the solid that's formed, and I want to know exactly how much solid is going to form. Yes, Bradley, you're the only one answering. Maybe you're the only one brave enough to answer. Are you guys tongue-tied? Are you guys confused? Are you guys just so confused you don't even know what I'm asking? What I did was I said, all right, if I have exactly this and I reacted with it in excess of this, then I will get 0.0625 moles worth of lead sulfate. Whereas if I had exactly, for the second part, if I had exactly that and I reacted it in excess of that much stuff, how much lead sulfate would I get? Well, I got 0.05 moles worth of that stuff. So the question is, what will actually happen? How many moles of the lead sulfate will actually be created? And here's my answer. I'm going to throw it out to you guys already. The answer is 0.0500 moles of PbSO4. The idea behind this is called limiting reaction. And it's a very subtle thing that I might have covered with you, and I wish that I had I think maybe I covered it with you too early. But remember way back when we were doing s'mores, and I told you if I had this many chocolate bars and this many marshmallows, and I gave it all to you, how many s'mores could you create? And then you told me, well, based off of the number of chocolates, you can only create this much s'mores. You would have extra amount of marshmallows left over, or something like that. Do you remember that? Do you guys remember something vaguely like that? Well, this is actually the whole point of me doing that mad exercise. And now a lot of the stuff from the s'mores lab is actually coming to light here, is this idea of limiting reactions. What happens is, what I'm saying is, if you have only a certain amount of solution number 2, and you have excess amount of solution number 1, then you can create this many moles of lead sulfate. Versus the first time when I did the problem, I said, if you had only a certain amount of lead nitrate and you had as much sodium nitrate or sulfate to react it with as you wanted, this is how much you would get. But which one actually happens? And the answer is the one with less. Because after you create 0.0500 moles worth of lead sulfate, where are you going to get the sodium nitrate, the extra sodium nitrate, to create the rest of it? That's what I'm saying. Do you guys understand what's going on here? We calculated that it takes 1.25 liters of sodium nitrate to create 0.0500 moles of lead sulfate. You Bradley was saying that we could create 0.0625 moles of lead sulfate. But here's my question to you, Bradley, is after you create 0.0500 moles of lead sulfate, where are you going to get the extra sodium nitrate, which you only had 2 liters worth of it to begin with, to create that? No. You need your 2 liters of sodium nitrate or sodium sulfate will only yield 0.0500 moles, no matter how much lead nitrate you react with it. And your 1.25 lead nitrate will only produce 0.0625 moles of lead sulfate, no matter how much sodium sulfate you react with it. So what I'm saying is which reaction will actually happen. And what I'm arguing is to say that the one that produces the least actually is the one that will happen. Because after you've produced 0.0500 moles of PbSO4, I'm sorry, you can't create any more because we ran out of sodium sulfate. Do you see what I'm saying here? So there's this concept of a limiting reaction or a limiting reactant. It's this concept of I can't create any more because I don't have any more of the raw material to give you to create it. So what actually is created, it's this guy right here. Does that make sense? So I guess here's another question is how much PbSO4 would be created exactly? How much? Okay, this is actually pretty straightforward. You take the 0.0500 moles of the stuff you created, and then you multiply it by 303.3 grams per mole. By the way, what do you think 303.3 grams is per mole? That would be the molar mass. So your answer is 15.2. So if I had exactly 2 liters of this stuff and 1.25 liters of this stuff, then I would get 15.2 grams of PbSO4 solid. Does that make sense to you? Now, why did I choose the 0.05 instead of the 0.0625? Well, that was the whole discussion that we just had. There's this idea of a limiting reaction. I wish I did the s'mores lab kind of closer to this concept, because that was better in stoichiometry. All right, but why isn't 0.05 mole PbSO4 already the amount of it? Why don't we multiply it? Why do we have to multiply it? Oh, I guess the question is, when I asked how much, maybe I should have said how much in grams. Because technically, if I said how much, this is actually probably a better answer. That's how many moles I created. But then we don't measure things in moles in the lab. I don't have a mole scale in the lab. I have a mass scale. So a good unit to give me would be 15.2 grams. So if I reacted, all right, here, let's see if we can find a reaction for this thing, like on YouTube or something. This was sodium sulfate, sodium sulfate reacts with and lead nitrate. I want to see what this reaction looks like. I want to see if there's an image. I want to see if there's a video. All right. Oh, okay, look. So check this out. Sodium sulfate, that's this clear liquid. Lead nitrate, that's this clear liquid. When you mix them together, it makes this yellow-looking stuff. That yellow-looking stuff is the precipitate. And if I were to dry that out, and I were to if I had exactly 2 liters of this and 1.25 liters of this at those concentrations, and I were to put that out to evaporate and dry it out and mass it or weigh how much solid I would have, it would have exactly 15.2 grams. And you can't make more than 15.2 grams because your sodium sulfate actually limited your reaction, how much reaction you had. You used up all of the sodium sulfate. Do you guys get it? All right, anyway, I didn't cover acid bases, and I wanted to cover that today. I didn't even talk about it. All we did was did one last example, but I think it was a very important example to do. Okay? All right, I'll talk to you guys later. That was a kind of a doozy of a class, maybe. What do you guys feel? All right, and then what I'll do is I will go and adjust your homework again. If there's a homework on acid bases, and since I didn't cover it, I'm going to move that to like next week Tuesday. Sound good? Yes. Oh, what are we going to do on lab on Wednesday? Well, I feel like actually what I want to do in lab now is figure out how to make a precipitation reaction and then dehydrate it and see if we can measure out exactly how many grams of this stuff that we make. What I'd like to do is actually do the lab that will actually show you this stuff in a reaction. I'll see if I can get my hands on the chemicals. All right. Yes, and the lab should help out with these concepts. Okay? All right. Talk to you later. Okay, bye.